Hello. We have been learning about areas of circles and different polygons, and we have talked about different aspects of circles and polygons. So let's review a little bit. The area of a circle is the radius squared times pi. So we can write it as A is equal to pi r squared. Or if we were to be given a diameter, the diameter is twice the length of the radius. So if we have a diameter, we just divide the diameter by 2 and we square that. Now, what happens when we have a segment of the circle? Let's say that this is a cake and you have taken a slice off the cake. How do you know if you have been fair to cut the cake so that everybody gets their share equally? So, to figure out sectors of a circle, let's talk about some definitions. So, a sector is the region bounded by two radii. So, AC and BC are radii of this circle, and they intercept arc AB. Okay, so the area of a sector is the ratio of the area of a sector of a circle to the area of the whole circle. Okay, and that is equal to the ratio of the measure of the intercepted arc to 360 degrees. So all we're doing is setting up a proportion of the area that's in blue to the entire circle and the measure of this intercepted arc to the entire circle. Okay, and we know that a circle is 360 degrees. So as a formula, we have the area of a sector ACB, so this sector, to the entire circle. And we replace the area of a circle with our equation pi r squared, and then the measurement of the arc AB to 360 degrees. Okay, so we have talked about in circles, circumcircles, and regular polygons. So let's go back a little bit to some definitions. A regular polygon is a polygon that has all sides congruent and all interior angles congruent. The circumcircle is the circle that is outside of a regular polygon. Notice that the vertices of the polygon fall on the circumference of the circumcircle. I know it starts to become a little bit of a tongue twister. The incircle is inside of the polygon, and all the sides are tangential to the circle. Okay, now if we look at this point C and go all the way to the vertex, that is the radius of the circumcircle. While if we look at point C and follow this line, the apothem, I know it's a funny word, it goes all the way to the side of this polygon. So the apothem, we give it the letter A, is actually going to be bisecting the side. Okay, so let's reveal some of the things that I just said to you. Okay, so the apothem of a regular polygon is the distance from the center of a regular polygon to the midpoint of a side. So here is my apothem, and here's my midpoint. For a circle, it is the distance from the center to the midpoint of a chord. Okay, and the properties of an apothem are that it's only regular polygons that contain it, and all apothems of a regular polygon are congruent. And it makes sense that they would be congruent because we've mentioned that it's just the radius of the incircle. Okay, so if I were to draw another apothem, let's see. Let's draw another one. So we're going to start from the center. And there you have it. It's just a radius. Okay, and if we were to draw some lines, let's see, let's pick this color blue, from the vertex to the center, you'll notice that we can form a triangle, and this would be the height of the triangle. Okay, so let's come up with a formula. The area of a regular polygon is going to be the apothem times the perimeter. And remember that the perimeter is just the sum of all of our sides divided by 2. Okay, so the apothem times the sides, so the side length, times the number of sides. So this is the general formula for any n-gon, so any polygon of any number of sides. Okay, so P represents the perimeter, and if we just want to write it in general, then A is the apothem, N is the number of sides, times the length of each side of the polygon divided by 2. Okay, I hope you find this helpful so that you can do some exercises.